Hello and welcome back to Build a CubeSat. I'm Manuel and today I have an update for you on how PCB assembly has been going. And as always, big thanks to PCBWay for sponsoring this video. On the upcoming test flight, I'm looking to fly 4 boards. The minimal EPS for power, the CM5 carrier board which will be the payload, and 2 MCU carrier boards to try out both LoRa and LTE communications. The assembly process has been pretty similar for all of these, but I did learn a few new tricks along the way. Let me give you a quick rundown of how this went. I got all of these boards manufactured by PCBWay and their quality is nothing short of flawless. Along with the boards, I have also ordered front and backside stencils for all of them. Step 1 is to prepare your pasting setup. I'm still using the spare PCB and painter's tape method and it continues to serve me well. So I make a tight frame with PCBs on a sturdy surface. Then I rub down the stencil and the board with isopropyl alcohol and take my time to get its alignment right. For pasting, I start by depositing a bit of solder paste above all the critical areas. I feel like there are a lot of strong opinions when it comes to choosing the right solder paste, and a bunch of people swear by Loctite GC10. Unfortunately, that one has become a bit hard to come by since Loctite sold their solder paste business and I never had a chance to try it. So for this run, I mainly used Chipquik TS391SNL and it has served me really well, so no complaints here. This is a type 4 solder paste and the number refers to how fine the solder powder in it is. The higher the number, the finer the powder. Type 4 has served me well in the past and also for this assembly run, with maybe one exception that we'll talk about a little bit later. The thing with finer pastes is that they tend to slump a little. This means after you apply them with the stencil, they tend to sag and spread out a little, which in the worst case can lead to bridged pads, especially if your pads aren't defined by solder mask. So as long as you aren't working with too fine-pitched components, you can maybe stick with T3 even, because that's just a bit easier to work with. So back to the pasting now. The more often I do this, the more I think that paste application makes or breaks the whole assembly process. What has worked well for me is to hold the squeegee at about 60 degrees, press down firmly and move downward in one continuous motion. It may sound silly, but breathing out slowly while doing this helps me keep the pace steady. At the end, I tend to pull the squeegee up, which lifts the stencil up too. And more than once, it's flopped back down and smudged the paste. So be ready for the stencil to lift too when you lift the squeegee. Also, it's a good idea to not get too much paste on your hands, so have a dedicated place to put the squeegee down on while you deal with securing the PCB and preparing the stencil for the next board. I did 3 PCBs the first time through and got consistently good results. When you're done, you can absolutely scrape up the leftover solder paste and put it back in the jar. That's in fact why I started buying jars instead of syringes. I then proceed to clean all the stencils with more isopropyl alcohol before the paste gets a chance to dry and harden. So once you're done pasting all of your boards, it's time to start placing components and maybe also question some of your life choices when you realize that you have used 61 100K resistors. What I found is that it makes placing a bit faster and less error prone if I keep my workspace somewhat clean and organized. It's basic stuff really. For example, you lose a bunch of time if you have to search for components while you're placing. So while I don't sort my components per se, I do keep them in 6 bundles. These would be general purpose resistors and caps, then special value resistors, other passives, ICs and connectors. For holding the board while placing, this SensePeak plate has served me well for years now. It comes with these little grippers that lift the board up a bit while holding onto it, and also they are magnetic and stay in place. As soon as you have a pasted board on your desk, you really want to avoid touching it unintentionally. So for me, everything above the board becomes a no-fly zone. If I need to grab something, I try to move my hand around it, not over it. I like to have a place where I can anchor my hand off board, so I usually have one of these clamps on the side where I'm placing from. And also there are designated places for components, tools and waste. And once I start placing components, I get into kind of a flow and it's easy for me to lose track of time. So I have to actively remember to breathe deeply, drink water and get up to stretch once in a while. For placing itself, I have the interactive BOM open as well as the schematics for checking stuff like which resistors set I2C addresses. As far as tools go, I mainly use straight tweezers. Usually I start with placing the passives, then ICs and then connectors. Everything down to 0603 I can do with just some decent lighting, but for the ICs and the connectors I like to use the microscope. I found this Vision Mantis pre-owned at a bargain price, so if you're in the market for a microscope, these are really nice. As you go through placing, you may notice stuff that you could improve the next time around. I got into the habit of jotting these notes down right then, because otherwise I would only remember half of them afterwards. Once I'm done, I transfer the PCB onto a slip of aluminum foil, and this goes onto a piece of perforated aluminum sheet stock. As you probably know, each solder paste has a temperature curve that's optimal for reflowing it, and if you have a proper reflow oven, you can program that in. But I only have a hot plate and a hot air gun, which I set up outdoors so I don't have to worry about the fumes. The workflow that has worked really well for me is the following. First, I preheat the hot plate to about 10 degrees Celsius higher than the peak of the reflow curve for about 15 minutes or so. Then I place the sheet stock with the PCB on the hot plate for 1 minute to preheat. Next, I slide the PCB on the tin foil onto the hot plate and let it heat up until smoke from the flux starts to rise. This takes about a minute for 4 and 6 layer boards and less for 2 layer boards. Then it will start to reflow, and if there are some stubborn areas, I hit them with some hot air from above, but I try to get the board off the heat within another 2 minutes, so 3 minutes total. I place the board back onto the sheet stock and let it cool off. A nice aspect of this solder paste is that it's really no clean. The boards come out looking perfectly. I inspected each board with the microscope, and I only found like 2 or 3 bridge pads on 9 boards, so pretty good. I think there are 2 things that made reflowing these go that well, apart from solder paste choice and proper application. The first being that the ENI G finish I got is just better for fine pitched parts. But the other one is also that the solder mask on these is just super precise. I mean, I have said it a bunch of times, but PCBWay just makes high quality boards. Now, with the front assembly done, the easy part was over, and it was time for me to figure out how I would assemble the backsides. I use a custom M.2 pinout that I call backbus to connect between boards in the stack, so I need M.2 connectors on both sides of the boards. Also, the CM5 uses 2 of these rather fine-pitched connectors that I probably dreaded the most. So I first tried hand soldering these fine-pitched connectors, which was just a mess and a non-starter. Then I printed these kind of jigs that would raise the back of the PCB to the same height as the aluminum plate I always use for this kind of thing, which allowed me to use the stencils. And this worked pretty well, but for the life of me, I could not get that solder paste to reflow by just hitting it with hot air before the connectors themselves would melt. I suspect that's because the 6-layer boards can dissipate quite a lot of heat. So then I reached out to Pierluigi Colangeli, who designed the CM5 Minima boards, which my CM5 carrier boards are based on. And he actually assembled the backsides first, just on a hot plate. And then for the front, he would have the PCB also on the hot plate, but with 2 coins as spacers, and basically use the hot plate just to preheat it, while hitting it with hot air from the top. That's a pretty clever way to do it, but my problem was that I had already assembled the front sides on 3 of these, and I kind of needed another solve. So after grappling with despair for a few hours, I finally remembered that I had bought some low temp solder paste a while ago, just on a whim, and this worked beautifully. Reflowed without a problem, just with hot air. I suspect it's not going to be an option for space-bound hardware, but by the time this becomes relevant, I hope that I have a proper reflow oven and some more experience with assembly. The low temp solder paste I switched to is Chipquik TS391LT, which is a T4. It worked well enough, but the CM5 connector pads are so slim that the amount of paste I got on them was just a bit too anemic for my taste. So I switched again to Chipquik NC191LT Type 5, which worked much better and reflowed just as easily with hot air. With the backside done, I moved on to the through-hole stuff, which mainly consisted of pin headers, the RTC battery clips on the MCU carrier board, the shield pins of the USB-C ports for the CM5 carriers, and these battery temperature sensors on the EPS. Also, the EPS needs some of these pin receptacles for the side panel connectors. We only need 2 of those on each side because as of now we only have the solar cells connected and no other devices on the side panels. This I did with some solder paste and a tip fine enough to skewer the receptacles with. And then lastly I press fit the receptacles for the battery contact PCB pins. So this was it for the bulk of the assembly. The most annoying bug I have found so far is that I have used the wrong footprint for the LDOs on the EPS. These are LT3045s in an MSOP package, And the footprint I used has a 0.5 millimeter spacing, but it should be 0.65 millimeters. I just barely managed to get them soldered on there with the top 2 pins left floating, which is okay because they are basically redundant. And it works, but it's super sketchy. Thankfully, this is going to be an easy fix for the next revision. Another thing that I couldn't really get to work yet is the undervoltage lockout. I'm pretty sure that the IC is wired up correctly, but somehow I must have picked weird bias resistor values because it just wouldn't turn on. I haven't put too much time into figuring this out yet, and it's also something for the next revision, but for the test flight this means that I'm just going to run the batteries into the ground, which isn't too big of a deal. So right now I'm working on bringing these 3 boards up, and I started by checking for obvious shorts with a multimeter. When I found none, I connected power with a low current limit, like 200 milliamps. And when this went okay, I connected a higher current limit, like 2 amps, through a USB and back bus. And so far, all of this worked just fine. Then I proceeded to write some MicroPython code for the RP2040s on the MCU boards. And next I will be transferring them from the dev board, which is a SparkFun MicroMod mainboard double, to my MCU carrier boards. Another bug I noticed there is that my solder nut positions are just a bit off, which I will also fix in the next revision. This is pretty much all I have for today. There is just one more thing I would like to show you. The UV printed memorial panels for the test flight just came in from PCB yesterday, and I am super happy with how they turned out. The colors are nice and vibrant, the coating seems sturdy, and overall they just look how I hoped they would. I actually can't wait to fly this. So there is still a lot of stuff that needs to get done for the test flight on June 15th, which probably means that I won't have enough time before then to put out another video. So I will wrap up the bring up of the boards, integrating the whole thing into the prototype, and writing some basic software in the next episode after the test flight. I will also try to stream the launch, so if you're interested, consider subscribing. And if you're looking for someone to fabricate and or assemble your PCB designs, I can highly recommend checking PCB out. You will find my affiliate link in the description, which will get you $5 off on your first order. Thanks again to PCB for sponsoring this video, and thank you very much for watching all the way through. Let me know if you liked this episode, and I'll see you in the next one.